Okay, so today we're going to complete the section on hypothesis testing for proportions. Remember, in case you've forgotten, 7.5 we are omitting, so omit this last section. Okay, hypothesis testing for proportions. So we're going to pick up with this example. We did most of this example in class, but I just want to run through it again. So we've got this research center that claims that less than 50% of the U.S. adults have accessed the internet over a wireless network with a laptop. And at this point, I really don't know which part of this question is most relevant. I don't know if the research center is focused on access through a laptop versus access through a PC. I don't know if it's about adults versus children. You know, we really can't tell the focus of the research center, so we'll just work with the information that we're given. Okay, so we know that so just reading this, we have a random sample of 100 adults. So I'm going to go ahead and highlight this information here. And it's important that we have a random sample because remember, we need to have a random sample whenever we're doing any type of hypothesis test. Okay, so if we know we have 100 adults, that tells us that our sample size, N, equals 100. Now it says 39% say they have accessed the internet over a wireless network with a laptop computer. This information is telling us that our p hat is equal to 39%. Right, so this is the proportion of our sample that satisfies whatever requirement we're looking at. Okay, now I want to take this time and actually remind you of the formula because you'll have p hat is equal to x over n. Okay, now p hat, this is your proportion. X is the number of successes, and n is the number of trials. So in this case, the trial is asking one person, hey, have you accessed the internet? You know, asking one adult, have you accessed the internet through a laptop and a wireless connection, right? And if they say yes, that counts towards your successes. If they say no, you know, it doesn't. So in our case, we've been told that p is equal to 0.39 and n is equal to 100, and so we can solve for x. So x is going to be 0.39 times 100, right, which is going to be 39. So in general, the way to find x is going to be p hat times n. Now, if you are, which you should be, using technology, TI-83 or TI-84, you're going to need to put in x, you're going to need to input n, right? You're not going to need to input p hat. So if you're given p hat, you need an n, you need to be able to figure out x. Okay, so let's go ahead and put this down just for future reference, that x is going to be equal to 39. And at alpha equals 0.01, is there enough evidence to support the researcher's claim? So of course I want to remind everyone that the very first thing that we need to do is verify that NP is greater than or equal to 5 and NQ is greater than or equal to 5. Okay, now this can sometimes cause confusion because you're thinking, you get confused between P and P hat. So when we need to verify that NP and NQ are greater than or equal to 5, we're talking about the hypothesized proportion. Okay? So reading this problem, we are told that the research center claims that less than 50%. So this 50%, this is going to be our P. Okay? So P equals 50%, which we can write as a decimal, 0.5. So that's why for P, we're using 0.5. N, we already said, is equal to 100. Okay. And now once you have P, you have Q, because remember Q is always 1 minus P. So if P is 0.5, then Q is going to be 0.5. And we're able to compute that NP, N, and Q are bigger than or equal to 5. So now we're ready to set up our claim. So our claim is that less than 50% of adults. I'm just going to kind of write this down here. So our claim is that less than 50% of U.S. adults access the computer through a wireless internet and on a laptop. So I'm just going to say less than 50% access internet. Okay, we translate that into a mathematical statement. Our variable is going to be P because we're talking about proportion. So we're saying that P is less than 0.5. We write the complement. P is greater than or equal to 0.5. One of these will be the null hypothesis and one will be the alternative hypothesis. For us, the null hypothesis is going to be P greater than or equal to 5 because remember, null hypothesis always includes an equality sign. Okay, so since we've got this equals in P greater than or equal to 0.5, we know that that statement is our null hypothesis. And our alternative hypothesis is P less than 0.5. So our claim is actually the alternative hypothesis. Okay, so we are going to go ahead and I've kind of filled out most of this. Let me actually, I think I can actually do better just by zooming in. Filled out this so you can kind of get an idea. Of course, what type of hypothesis test are we doing? We're doing a hypothesis test for the population. The requirements are NP and NQ are greater than or equal to 5, and that we have a random sample. And we actually do have a random sample if we look back in our problem, because it said we have a random sample of 100 adults. Now, the null and alternative hypothesis, we have figured those out, and we checked that the claim is the alternative hypothesis. State the distribution used for the test. We'll be using the Z distribution. Whenever you have a hypothesis test for the proportion, in this class, whenever we're doing a hypothesis test for the proportion, we'll use the Z distribution, okay? Because we're having NP and NQ greater than or equal to 5, so we're approximating our distribution, the binomial distribution, by a normal distribution. So the test statistic is going to be p hat, and we were told that p hat is equal to 0.39 or 39%. Okay, and the standardized test statistic. So we've got two different ways that we can find the standardized test statistic. One way is to calculate it with the formula, and another way is to look at the output from your TI 83 or TI 84, right? Whatever your calculator is. Once you do the one prop Z test, the output will be Z, your P value, and your P hat, which is your statistic, your test statistic, the standardized test statistic, and the P value. So to see the formula, if you like to do it the old-fashioned way by hand, this is our formula for the standardized test statistic, and general is right here. So we've got Z equals P hat minus P naught divided by the square root of P naught times Q naught over N. P naught is your hypothesized proportion, so it's going to be 0.5, okay? And then Q naught is the probability of failure, right? So it'll be 1 minus P naught, so that'll be 0.5. Okay, the N is 100, we had that from already, and the P hat is 0.39. So when you do that, you should get your standardized test statistic equal to negative 2.2. Okay, so that's why we have here that our standardized test statistic is negative 2.2. Okay, so we've done that. Now, what is the p-value? Again, you're going to go to one prop, z-test, you're going to enter in the information about n, x. You'll also need to figure out if you'll need to enter the type of test. Is it left-tailed, right-tailed, two-tailed? To determine the type of test, you look at HA. So since H sub A, which is our alternative hypothesis, has a less than sign, that means we're going to be doing a left-tailed test. Okay, so on the calculator, you'll need to indicate that you want to do a left-tailed test. Okay, so that's something else, and we have that indicated here. Now actually what I want to do is this is one way to fill this out, is to have the p hat down here. Another way, which would be also correct, would be if you were to label this as z, right? So if you labeled it with the standardized test statistic, that is also okay. Now I'm not too much of a stickler for this. Essentially what I want to see is I want to see you indicate whether we're doing a left-tailed or right-tailed or a two-tailed test. That's what I want from this picture. So when you enter that information into your one prop z-test, you should get that your p-value is 0.0139, and we have here what that means. Explain what the p-value means. Okay, so what I'm going to do is I'm actually just going to leave this up on the screen for a few seconds, and so you can pause, you can take a moment and make sure that you understand why I answered the questions the way that I did. Okay, and so remember, in order to make the decision, you check which is greater, p or alpha. And so here we had alpha is 1% and our p is 1.39%. So since p is greater than alpha, we fail to reject. Okay, so there you go. I'm going to now move on to so this is the way to answer it using the rejection region. Okay, and the slides are online as well. I'm now going to look at example 2. So it says research center claims that 25% of college graduates think a college degree
1330.
Thank you. Is not worth the cost. You decide to test this claim. So you're going to test this claim. What is your claim? Your claim is that 25% of graduates think a college degree is not worth the cost. So the claim is going to be P equals 0.25. And we write the complement of it, which is P is not equal to 0.25. H naught is going to be the first statement. H sub A is going to be the second statement. So our claim is going to be H naught, the null hypothesis. Okay, we sampled 200, so that means N is equal to 200. And of those surveyed, 21% reply yes. So P hat is equal to 21%, so that's 0.21. And X, which is equal to P hat times N, is going to equal 42. Okay, now at the 10% level, is there enough evidence to reject the claim? So the first thing we're going to do is verify that N times P is greater than or equal to 5 and N times Q is greater than or equal to 5. So we can go ahead and write down what is P. Now this P and Q is your hypothesized proportion. So P is going to be 25%, 0.25, and Q is 1 minus P, so that'll be 75%. Okay, so we can check, and NP and NQ are in fact greater than or equal to 5, because one of them is 150 and the other is 50. And now, so we can go ahead, and I've gone and filled this in here. Of course, we're conducting a hypothesis test for proportion, right? We have the same requirements, right? For any hypothesis testing with one sample, these are your requirements. We have our null and our alternative hypothesis. The claim is the null hypothesis. We'll be using the z distribution. Now, what is the test statistic? It's going to be p hat, okay, which is your 21%. Your standardized test statistic, we can calculate it with the same formula as before. Also, it should come up on your calculator. Remember, you're going to be using one prop z test, right? And so when you finish entering in N and P, and you determine that it's going to be a two-tailed test, right? You get the output is your p-value, your test statistic, and your standardized test statistic. So again, I have the explanation of what the p-value means, right? The probability of obtaining a sample with proportion as extreme or more extreme than 21% is about 19%. So if there's a 19% chance, that's not unusual at all. That's like, that's a large percentage. And so even though our alpha is 10%, because our p-value is almost 20%, we're going to fail to reject H naught. Fail to reject. The reason for the decision, because p is greater than alpha. And our interpretation is that there's not enough evidence to claim that the population proportion is different than 25% at the 10% confidence level. Okay? So if alpha equals 10%, then no, we're not able to support the claim. All right, and then lastly here, this shows you the nitty-gritty for how to compute the standardized test statistic. Right, how to get that. So this is the standardized test statistic. Standardized test statistic. And this shows you a picture. This is using rejection regions. And we are done. Thank you.